All right, so this video we're going to go over the replacement rules, and we have 10 replacement rules. And so that's all that we have for the proofs. We have the 8 implication rules and then 10 replacement rules. And so those are all the rules we have when we're doing our propositional proofs. I'm going to go through over each one of these, but the main difference between a replacement rule and an implication rule is that the replacement rules can be applied to parts of the line, so they don't rely on the main operator. And I'm going to go through this as through the example, but also when I go over each step. So let me zoom in here, and let's start with double negation. So double negation is really, really simple. If we have some statement P, you can say not P. Those are logically equivalent. They're going to have identical truth tables. And if we do one replacement like P to not P, we can also go from not P to P. So if you see two negations in a row like this, and that's ugly, it's hard to work with, you can just get rid of that and put the statement instead. So you can just, they cancel each other out. It's a double negation. Again, that's a very simple in terms of the way that we use double negation in real life, in ordinary language. Okay, so that's one of the easier ones. Commutation, this one is very easy as well. And we went over this one when I went over the truth tables for conjunction. So this is if we have P or Q, we can just flip the disjuncts. We can write Q or P instead. And the same thing for conjunction. If we have P and Q, we can flip the disjuncts and get Q and P. So maybe your conclusion is Q and R, and you end up proving R and Q. You just have to do one instance of COM on that line, and you'll get the conclusion that you need. Okay. This association is also pretty easy. So this one has to do with the parentheses. So we start with the statement P or, and then parentheses Q or R. We can easily just move that parenthesis over to P or Q. So we can get P or Q or R. The main point here is in the statement, they all have to be disjunctions or they all have to be conjunctions. So if I say, who is a dog, or Molina is a cat, or Murphy is a cat, so those are my two cats. And so I have grouped Puma is a dog, and then Murphy's a cat, or Molina is a cat in the parentheses. It's a disjunction, right? So for that to be true, just at least one disjunct has to be true. So if Puma is a dog, if that's true, the statement's true. If Murphy is a cat is true, then this whole thing's going to be true. And if Molina is a cat is true, then the whole thing's going to be true. So the parentheses, when it's an entire string of disjunctions, we still need them for the reasons I talked about last week with the ambiguity. So like if there's a disjunction in the parentheses and it's attached to a conjunction, we are going to have an ambiguous statement if we don't have the set of parentheses. But when they're all disjunctions, the parentheses, the only role that they're doing is maintaining consistency in terms of identifying the main operator. But in reality, they're not really playing a role when they're all disjunctions or they're all conjunctions. So we're able to use this association to smooth the conjunct or the parenthesis over if we need to. So in this case, the parentheses are around Q or R, and now with association, we can get it around P or Q. Association, same thing. We have P and in parentheses Q and R. We can move that parenthesis and get P and Q and R, where the parentheses are around P and Q. So that's another pretty easy one. Again, it's just moving the parentheses, and the main thing here is that every single operator has to be the same, either disjunction or conjunction. So I did the truth table for De Morgan last week. And so this is a case where you have a negated conjunction. You can distribute that negation to each conjunct within the parentheses. But that conjunction turns into a disjunction. So from a negated conjunction, we get a disjunction where both disjuncts are negations themselves. And of course, this goes the other way too. So if you have a disjunction where both disjuncts are negated, you can pull that negation out and get a negated conjunct where the conjunctions within the parentheses are not negated anymore. And De Morgan also works the other way, where you have a negated disjunction that can turn into a conjunction where both conjuncts are negations. So when we're doing De Morgan, we are distributing that negation, but we're switching our conjunction to disjunction or our disjunction to conjunction. Now, an interesting thing with this one is that, let's say you had not the case P and not Q, you can still use disjunction. But what you end up getting is not P or Q. So whatever value you have within the parentheses, it's going to flip. In reality, what you should get is, let's say it's not P and not, so it's not the case P and not Q. You'd actually get not P or not Q. And then you would use double negation to get not P or Q. I think even when I said that, I accidentally did not switch that main operator. So that matters. So not the case, P and Q turns into not P or not Q. But if you have not the case P and not Q, that would turn into not P or not Q, which then turns into not P or Q. Some of you might skip that double negation step, but I won't take points off for it, but I think it's better to spell out every single step, because that's the whole point. Like, there is no reason to be doing these formal logic proofs unless you really want to explicitly spell out every single step. But it's really easy to skip double negation, or just like neglect to add that double negation and then go through that double negation step, especially when you're going through the proofs. So that's De Morgan, again, distributing that negation and flipping that sign. And then on the other side of it, pulling the negation out from both and then flipping that sign when you put those two parts of the statement into your parentheses. Okay. Now let's go over to distribution. So this one is pretty tricky, but I think, again, if you have mastered the concepts of conjunction and disjunction, it will make sense. So here we start with P and then within parentheses, we have Q or R. So this one, we can distribute that conjunction to each disjunct within the parentheses. So what we end up getting is P and Q or P and R. And how does that work? Well, once we have P and Q or R, it's a conjunction. So we know the P is true, and we know that Q or R is true. We know that Q or R is true, but we don't know whether Q is true. We don't know whether R is true. We don't know whether both are true. Because we don't know which one is true and which one isn't, this replacement rule is saying, okay, P and Q is true, or P and R is true, and then maybe both are true. And when we're looking at this disjunction statement that we've created, we know that P and Q is true or P and R is true. And from this, we know that either P is true and Q is true, which would make it the case that Q is true over here, or P is true and R is true, which would make the case that R is true over here. And since we have a disjunction, it could be the case that both end up being true. But because that we know that P is true, that's how we're able to distribute it to both of these disjuncts. But that main operator changes from a conjunction to a disjunction because we don't actually know which disjunct is true from our original statement. Now, disjunction also distributes. So we have P or, and then in parentheses, Q and R. What this is saying is that P is true or Q and R is true, or both is true. So again, we're going to distribute that P to both conjuncts, but that we're going to change that disjunction into a conjunction. So we get P or Q and P or R. So now we know that P or Q is true and P or R is true. But the only reason this works is that even though we don't know whether P is true, even though we don't know whether Q and R is true, we do know that P or Q is going to be true because that's the nature of this disjunction. And we're going to know that P or R is going to be true. So that's the nature of this disjunction as well. We just don't know which one is actually true, Q or R. Q or R or P. But we know at least one of them is going to be true. And because at least one of them is going to be true, that's going to make this entire statement true. So like, let's imagine that P is true, Q and R is false. This statement is still true because it's a conjunction made out of disjunctions where each disjunction has P in it. So if P is true, then this part of the conjunction is true because it's a disjunction, at least one is true. And if P is true, then this part of this disjunction is true, or this conjunction is true because it's a disjunction where P is one of the disjuncts.